So for the percentages, right, for the percents, anytime you're doing a percent, it is part that you care about over the whole, right? So let's say you take a quiz and you get 7 out of 10. Well, the part you care about is the part you got. That's 7 divided by 10 times 100. So you got a 70%, right? So you take the part you care about divided by the whole. So if you want, for any kind of percentage. So if we're doing the percent that's magnesium, we would do the mass of magnesium over the total mass, not over the other mass, over the total mass, right? Times 100, of course. So again, just like I labeled these, mass magnesium, and then did that. So this is the idea of what I'm going to do, and that's not a bad idea to write down, but what I would for sure need to do, and I think this is the fourth calculation, is I would do the mass of magnesium. So I'm going to write down percent mg, so then I should have labeled real easy to find over here, your mass of magnesium, do not use my numbers, divided by the total mass, that's the mass of your final product, right? 1.6 grams times 100 gives us whatever, and then the percent oxygen, we would do the same thing, but with the oxygen part, so 0.60 grams divided by 1.60 grams times 100. And again, if we, common sense should tell us, whatever percent isn't magnesium, it should be oxygen. So if I get 50% here, this should be 50%. It's not 50-50, but we should be able to do those as well. Right, so our percent on this is 62.5% magnesium, 37.5% oxygen. These are not good numbers. I just made them up. So don't think that like this is what you're supposed to get or something like that. But a percent composition is a way we can identify chemicals. So this is a thing that's not incredibly difficult to do in lab. And then by mass, we can figure out a percent composition of what something's supposed to be. And then we can figure out what it is and see if it's what we're expecting it to be. Right, so it's a very practical thing for chemists to do.